And let me just briefly remind you about fat tails again. So you remember we had the example of the distribution of pandemics, where you had one pandemic that could kill more people than like almost all the rest combined. And then you had, so in the lower panel here, you have traffic deaths in Finland, and you see that the change year to year isn't really too large, and you would not expect that one day there will be 100,000 uh, traffic deaths, because that would be just absurd. There's no real mechanism for a car uh, crash that would span the length of Finland, for example. And we had this example where we have these two distributions on a logarithmic plot. And on the top one, we have the pandemics. On the bottom one, we have the traffic deaths. And the traffic deaths, it curves downward very steeply. And we can expect that if we collected more and more observations, the rest, it would eventually become sort of almost vertical, this curving, the most extreme observations. So all extreme observations would resemble the past extreme observations or be milder than those. Whereas in the top panel, you see that the line is actually, it fits quite nicely a straight line. And what this sort of allude to is a phenomenon called power law scaling. So what we might expect in a situation like this is instead of having regression to the mean, something that Ben Flubia calls regression to the tail, where the new extreme observations can be expected to be even more deadly than the previous uh, extreme observation. And and it could be a lot more deadly also. And in this situation, you might have, it's quite so the past data doesn't really tell you what you should prepare for. You should prepare for something that is way more drastic than what the past data tells you. And there's one way of visualizing this in another way is that we have sort of the line that used to be blue in the previous plot that goes through here. And we have the event sizes on the logarithmic scale as the ball sizes of the balls here. And this is just a schematic, so don't get too deep into the details. But so here we have these, we could think that, so here, can I get the laser pointer? Oops, no. Yes. So here we would have the domain of pintails. So we would have the pintailed distributions here. And so they're quite small and homogeneous in comparison to these events here. And so you have a nice place where you can play with the traditional statistics. And on the other hand, here we have the fat tails. So highly heterogeneous events, and one can be larger and or more impactful than all the others combined. And a few because they are sort of rare and the rare-ish, so they're not like once in a billion years event. They're more like, in the case of pandemics, like once in 100-year events or 50 years. and the same with wars. So we don't have many observations to draw conclusions from, because by definition, the tail events are sort of novel. And so future observations can differ from the past, and the past events are of limited use in making inferences about the future. And what this sort of leads us to is the dragon. So let's talk about dragons a bit. And so in the olden days, you had these warning signals in maps where they drew up dragons and other strange beasts. And they were to say that, yeah, you don't really want to go here. And that sort of makes sense because there are risks that really shouldn't be taken. You shouldn't try playing Russian roulette repeatedly because no matter how you uh, might flourish, uh, if you win, like dying actually destroys all your future opportunities to be a good person and a happy individual. Uh, it it might be actually that the society benefits. So if you do a crazy experiment where you risk your life, or you're in a profession like a soldier or a policeman or a fireman or something like this, then society benefits from your risk taking. And of course, society also benefits from many other risky professions, such as restaurants. Most restaurants go bankrupt, but this also guarantees that we have variety in food and have a nice selection of what to choose from, and that selection is constantly renewing in time. And so, but as a general rule, you might not want to go to places which can end all your future adventures. So you can take all the risks you want, but don't take as long as you understand that there is a risk. So in many cases, you have these situations where there are mathematical models that show you that there is no risk, and then suddenly there is financial collapse. And we can use this what we talked about, fat tails and risk, to try and understand what uh, where data is good, or when is data analysis helpful. So if we have binary data, so something is 1 or 0, then you, in the case of pintail, you're very safe. You know what to do. It's just common sense. You won't get um, a series of 1,000 times in a row if you're throwing a coin. If you have unbounded data, then you can use statistics. So it's sort of safe if you know what you're doing. And even fat tails, if you have binary data, you might be able to ensure that you have, if you see this very long streak of ones or zeros, you might be able to ensure your losses. These are when binary data is important or meaningful in a societal context, those situations are quite rare. Because most of the societal data is unbounded. And you can't really just make unbounded data binary by recoding your data set, of course, because then you're just operating within imaginary data and not the real world. Because often when people are looking at the connection between income and IQ, for example, they truncate the data set and say that everyone above this income is the same. So this is the same discussion we had with the Likert scales, so that everyone who answers 5 are sort of the same. And it doesn't matter if they would have answered 5 or 1,000 were they given the option. But in the case of fat tails and unbounded data, that's where the analysis gets really dodgy. So you need to use something else than conventional statistics, and there are ways such as the extreme value theory and other sophisticated methods that can be used to evaluate how large a risk of these rare events poses.